In this video, we're going to look at the logarithm rules, or the properties of logarithms, to do two things. In one problem, we're going to take this string here and write it as a single logarithm, so that's called condensing. And in the second problem that we'll do together, we're going to expand this single logarithm into a summation or difference of logarithms that have exponent 1. So we're kind of be doing the opposite thing. So we're going to start with this one. So we want to have a copy of the rules in front of us. And so these are the three main ones: the product, the quotient, and the power rule. So if I'm going to start this, when we're condensing, we need to read these rules from right to left. Okay, so we want to take something that's long and we want to condense it. So we're going to be reading them from right to left. And so the first thing that pops out with me is these numbers out the front here. So I'm going to be using rule number 3 to each of these. So if I use rule number 3 with that, then I'm going to have a power here of 1/2. And notice also they have all the same base. Now I'm going to copy that subtraction sign, and then I'm going to use rule number 3 just to what I've circled there. And again, I'm going to copy the subtraction sign and just use rule number 3 on what I've got circled. Okay. So what I'm going to do next is I'm going to look at these two. And I have a difference of logarithms and they have the same base. So I'm going to use rule number 2, reading from right to left, to combine that into a single logarithm. So I'll have a quotient, and what will go up in the numerator is what I have here. And what will go in the denominator is my argument there. And then I'm just going to copy the rest of that. Okay. And now I have another difference of logarithms, so I'm going to use rule 2 again to combine these into one expression. Now what's going to be in the numerator? Well, everything that's inside here. And what's going to be in the denominator? Everything that's inside there. Now, it is true that I have now written this as a single logarithm, but you would never see this answer presented like this in a multiple choice test or in the back of the book, because what we have here is a complex fraction. So if we have any fractions in our answer, they have to be simple fractions. So I've got to write that as a simple fraction because it's a complex fraction. So what I'm going to do is, so in the numerator, I've got that. And in the denominator, I've got z to the 3/5. Now, I'm going to make that into a fraction just by putting it over 1. And so what I have here is this fraction divided by this fraction. Now, what's the rule when you're dividing fractions? Well, division becomes multiplication. You keep the first term as it is. Division becomes multiplication, and then you flip that one, take the reciprocal. And of course, now that I'm multiplying fractions, I just multiply the numerators and the denominators. So, if I get back to here, this will be that. So I'll have x to the 1/2 all over y to the 8th and z to the 3/5. Okay, now this is a correct answer, but the fraction isn't simplified. This is a correct answer. Lots of times the books or multiple choice questions put it in radical form. So for the final part, what is x to the 1/2? That's the same as the square root. And I've got y to the 8th. And what is z to the 3/5? That's the 5th root of z cubed. So either one of these forms is correct, and you would see it like that, either one of those, 50-50 in the back of the book. You wouldn't see it like this. You have to make that fraction, change it into a simple fraction. All right, now what about this? Now we're going to do the exact opposite. We're going to start with a single logarithm and we're going to expand it. Okay, well when I look at this, what I have here inside these parentheses is a quotient. I don't have everything to 1 power. I don't have a product. I have a product here, but it's in the denominator of my quotient. So I have a quotient. And now if I'm going to expand, I need to read these from left to right. So I'm going to use the quotient rule first. So rule number 2. And rule number 2 says I can rewrite this as a difference. And what will go in here is what I have in the numerator. And what goes in here is what's in the denominator. Okay. Now I can use rule number 3 on this. Okay, and using rule number 3, that 5th power is going to come out the front. All right, now what about this? Well, what I have in here is a product. I'm not going to use rule number 3 here because I don't have everything raised to 1 power. Now what we have to realize here, I'm going to copy this negative sign, this subtraction sign, and if I'm going to use rule number 1, which is the product rule, I'm going to change this single term into 2 terms. I've got to put it inside parentheses because the negative sign is going to have to apply to everything. So when I use rule number 1, just what I've circled here is going to be the natural logarithm of y squared plus the natural logarithm of z to the 7th. Okay, and make sure you put the brackets there because the negative sign is going to have to be applied to every term. I'm not going to do it just yet. If you want to go ahead, that's all right, but I can use rule number 3 on this guy, and I can use rule number 3 on that guy because now we've got the single things raised to a power. So the 2 will come out in front of this one, and the 7 will come out in front of this one. And the last thing I have to do is distribute the negative sign right the way through. A lot of students will forget to put the brackets, and they end up with the negative sign only being on that first term, and then they write a plus sign, and it's wrong. So our final answer, and then minus. That's what our final answer should look like. And that ends the video.